not ready, but that's okay. I was going to, I was waiting on a piece of equipment to be able to allow me to have everything on the one screen, but I'll manage with this camera here. Now, while I don't really use ESP32 you may know that I use the parallax processors, the propellers. Some of you may be familiar with these processors. Back in 2006, Parallax, they designed their own silicon, and they came out with a 32-bit 8-core processor. This wasn't a big powerhouse, but it was essentially 8 processors with a central hub memory, and each processor had local memory, and they had 32 I/O. And around those 32 I/O, those 8 cores or cogs could access any I/O. And so it was very good. It didn't have interrupts, and 32K memory was 32K ROM, 32K RAM total. It had limitations there, but it proved very useful because you could get one of those cores and say, you are now a UART, for instance. Or you might say, you're 4 UARTs. We can get it to do that as well. And other cogs we could get specialized. The whole idea of the cogs was so that you could create peripherals from those cogs, and of course, processors. Now, that came out with Spin in the ROM, and Spin tool. And Spin is a bit of a Pascal mix, etc. And it was very easy to learn, very easy to get everything up and going on it. But after a few years, after quite a few years, I really wanted to get back into Forth. And so I developed a Forth for this processor that made most use of the processor. So it's a machine Forth. And initially it started out as a bytecode Forth. So this is 2012, and I had VGA running and then Ethernet running, etc. I've used some products right back then. You know, I have his original propeller chip right here, and that was built into products, or I don't know, hundreds of products, all industrial controls and commercial equipment and so on. Even built into this little module here, and you see a little, there's a little propeller chip down here, and a little SD card, etc. And so I wrote FAT32 routines for SD card as well. And by the way, I'll just show you something too. This is the sort of application that these things might be used. And see this? Well, that's a 1000 amp brick SCR. I have about 40 of them in a regulator, but this was designed to clip onto the terminals there with DC isolation, everything else, and connect via 485. And that with that Tachyon Forth, I could come along from any other unit, use it as a gateway to talk to any unit as if I was talking on a serial console. We're used to a serial console, and we can just chat with that particular device. And so I could address them as a group and address globally or individually. So very useful, very handy for debugging. I could stand safely away from the equipment because one little mistake and it wasn't pretty. It wasn't pretty at all. So that's the sort of stuff that gets used there. And that's propeller chip. But Chip Gracie, who designed the propeller chip, started working on the successor to it. And about 2015, we're playing with FPGA variations of this, and I ported my Tachyon Forth to the P2. Very similar architecture, enhanced. Eventually, that P2 became silicon, and we're familiar with the silicon here. I have a board here. Here's one board here. Here's a P2 chip. Compare that to the original propeller chip there. We see the slightly larger package, more pins, 64 I/O. Still 8 cores, but they're much faster internally. much more powerful internally, and they have 64 I/O, and every one of those I/O is a peripheral, smart peripheral that can be configured. And so it makes this a very powerful processor. And on top of that, we have 512K of RAM. Now, guess what we can do with 8 32-bit cores that, well, we can run over 300 megahertz at 300 megahertz. We can generate video, we can generate all kinds of signals. And in fact, you know, we can output frequencies, analog in, analog out, anything. So that when that became silicon, we had 16K of ROM on board this chip. Only needed 2K for the bootloader, for the serial and flash bootloader. One other guy decided he wanted to do the SD bootloader part of it, and we combined the SD and the flash into the same 4 lines. A few tricks there to do that. And what happened was that, well, I had 12K, and what could we put in 12K? Well, you know, the only thing that was useful was Tachyon 4th. They didn't really like the idea of 4th, and they didn't want it to be identified as a 4th processor as such, but we had, it was renamed into Tachos, T-A-Q-O-Z, and so we see that has the Tachos in ROM, and it's very useful for debugging hardware. If nothing else works, that will work, and I can talk to it and debug the hardware. Of course, what I tend to do is load on a much more powerful version of Tachos, more updated version into it. And I'm just going to show you that now. This isn't perfect. The idea was that I would be able to share straight from the screen, my webcam, everything on one screen. It mightn't be very clear, but I'm just going to turn the camera around and show you a system here. I'll see how this works. Okay, over here we have, how's that working now? That's a bit back to front, isn't it? Yes. This wasn't mirrored before. Something's happened here.
It's not mirrored. It's not mirrored. It's perfect.
Oh, okay.
It's mirrored to you.
Good. Oh, yes. Yeah, as I'm looking on my monitor here, it's always good to have a separate connection for Zoom there. So very good. Thank you. And so what I have here is the VGA output from one of these units down here, one of the boards down here that I have, my little test unit, one of my original units plugged in, and I have VGA going out. And rather than trying to show a separate monitor, I fed this back in picture-in-picture on this monitor here. It's not perfect. I can't share that on Zoom directly as a screen, but I can show you via the camera. And so if I can zoom up again, this was all working fine before, but it won't let me zoom in now. However, over here, I have the output, the VGA output. I'll just talk to this unit here. Now, I use Visual Studio Code editor over here, and source code. I can open up a terminal, extra terminals, etc. You mightn't be able to see this very clearly, but what I'm going to do is just simply talk to the VGA screen, tell it to clear the screen. I did say clear screen, didn't I? I know what's going on. I'm in the middle of a definition. Okay, there we go, clear screen. I have the colors set to 8-bit color. And so I've got my other webcam up here so you can see me talking up in here. And so I have output there. This unit at the moment is running at, I'll come up here on the screen. I'll change my resolution on the screen to 180 lines. All right, and then basically talk to the screen and let's see if we can see something on the monitor here. Can we read that? I can probably go a tiny bit larger than that. I'm not quite sure. 120p. Let's see if I can go to do that. 120p. Yes, I can do that. So what I might do, you can certainly see that now. So I've just changed the resolution of the VGA. I can go, well, I change it from anything from a few pixels wide to 1920 by 1080. And so this is only just running out of, the VGA driver is running out of one core, but it could be run out of the same core as Tachyon is running, and Tachyon can be run out of any core, multiple instances. So you heard of multitasking. Well, of course, that slows things down, but here we can just have it running elsewhere. Just to show you a couple of things that it can do. First off, we're familiar with stacks, etc. We can see fourth working there. Whoops, just do this again. And even that low resolution, you can see that running there. Now, what I'm going to do is just drop that back to 640 by 360, just to show you some of the capabilities of this. I should really clear the screen there. I'll do a directory of the SD card, and on there, I've got a bitmap. I'm just going to look at that bitmap. Let's have a look at it. Minion. This is a minion. Okay, so that took about 40 milliseconds to read in and flip and everything else, etc. on there. I can also play movies, but at the moment I have a bug, so I'm not going to go into that at the moment. But just change the palette on there. Let's do something exciting. You all like a bit of music, right? So let's go back. Let's open up the WAV file directory. Let's look inside the WAV file directory, and let's play something like play read. You can hear that. And then while we're at that, let's go back, view the minion again, and do something with that music. Let's modulate that with the music. I'm hardly taxing the processor at the moment. I have plenty of cores sitting around twiddling their thumbs, waiting for something to do. So if I had a real-time task, I could be running in another cog and it wouldn't pick up the slightest bit here either. So I'll just stop that now. Well, I'm still talking there. Okay. All right, so I've just stopped that now so you can hear me speaking. So that was just a small demonstration. That's all running forth. All the code is right there, various modules that are loaded. I'll see if I can show that on here. That even shows perhaps some of the modules that are loaded in here. I have a fractals with Mandelbrot breakout game written in forth. Very simple game too, mind you. Why don't we have a little look at that, see how that works. Breakout. It's doing something. Yes. Of course, I can make it go very fast, but and very slow. And I think I can even make it do much larger ball. I won't miss that ball. All right. So that's just a few little things we can do there. And but while I'm showing you the VGA, the important thing to remember about this processor, it's a real-time processor. You have the cores and you have signals coming in. You don't have to worry about interrupts or anything else getting in your way. You can dedicate that core just to handling the task. And so this is what I've done in a lot of situations. One of the original applications I had 12 channels of these matchstick type photo cells, etc. For pill counting, it would measure the shape and speed, size, etc. of it, and it was able to do all that, and just with simple little microcontrollers. I wasn't running forth at the time, but everything I do with this processor now I do in forth. Now I'm just thinking too that, like, you're probably familiar too with various I/O, like over here I have some WS2812 LEDs. There's nothing special about them. That's just one little stick. But what I might do is up here on the VGA screen, I might go back to a low resolution so you can see what's being typed up here, and clear the screen up here. Now that particular That particular one is up on, can't think which pin it's on. I think it's pin 32. So I'll say 32 pin. And I'm going to just pass a buffer. It happens to be the dictionary to it, 24 bytes. And I'll tell it to send it to that. There it goes. So that's as simple as that. We can, of course, have another little task. Let's go and create a task in a cog, which just refreshes that LED. Now, it's, you know, it's not making full use of that particular cog, but we're just going to do a nice simple definition. LEDs, we'll call this, and all it will do is sit in the loop, go, well, we should actually give it a buffer area, but it doesn't matter. Specify the pin it's going to use and tell it to, I'm just going to borrow from the SD card buffer here for the moment, and 24 WSTX. I'm going to wait 10 milliseconds between that. Can't remember the reset time for it and the gain. All right. So we can see that up there. Just making sure I can monitor this. All right. Now, just make sure that it's right. Let's look inside that LEDs, 32 pin, SD buff, 24, etc., etc. And then this basically just tells it to jump back to that particular spot there. So theoretically, I should be able to get that to run. So I'll just basically release that pin there at the moment by letting it float, and tell this one, tell this to run in cog6. Run, what was the name of that one again? LEDs, I think. LEDs. And SD buffer has nothing in it at the moment. So what we're going to do is just put a value in there, SD buff. I don't think it's going to be enough, that one there, but we can see a little green light perhaps. So what I'm going to do now is just get this to work like this. Begin a loop where I just run through and increment the SD buffer in the 32 bits at a time. So let's go SD buffer plus, and until I hit a key, keep going doing that. And so we're just cycling through all 32-bit values. It'll only be one LED at the moment because pretty much, and plus maybe one other LED after that. But as you can see, that's just running in the background. I think it comes up okay. And of course, I can get a lot fancier than that. But whatever I throw in that buffer, if for instance I copy, let's go fill that buffer, SD buffer is 24 bytes of 40 fill. All right, so there we go. So that's RGB values, not too bright, and let's just turn that all up. So that's nice and easy. And to blank it all, I can just tell it, give it an address of 0, which tells it to blank the display. Except I have it running in the background. I think I told it like that, and stop the cog like that. So we can just stop the cog now, and I can come along and override that. Now I can tell it to blank the displays. That's just a very simple demonstration of how I can run that in the background. For instance, when I was playing that music before, let's play that too again. Let's play something different this time. I can't read all that. On video, I'm going to do both. I'm mirroring my output onto the VGA and onto the terminal here so I can see what I'm typing a bit better. And I'm going to play Sharona. Everybody likes my Sharona, don't they? Sharona. Still modulating. And in the meantime, I can still, didn't like that too much, did it? There were a lot of words there, but that's running fairly well. I'll just tell that to stop now. I can control the volume, pitch, and everything else, and so on. That's just running in the background. So there's a few things there. How am I going for time? I'm just 20 minutes about up at the moment, but what we can do with this, of course, mentioned that we can generate signals in real time, and any smart pin I can assign a pin. Have you ever seen this, for instance? I'll just try this out. Let's try this. Next time I'll have a scope diagram up on the screen at the same time. I've lost my mouse now. It's down here, there it is. Okay. Here we are. Now back here again. And so what we'll do is we'll change over to terminal colors. So we can see, not very good. I don't know what I'm doing at the moment. I'll just change back to 1080p. What happens 1080p? You won't see anything up here because it will be that fine. And if I type anything up in there, we have very fine text over here. So yes, it's very handy for graphics, but I can only do it in mono with that amount of memory. So I'll switch back to 360p with 8 bits per plane, 360p, and oops, 360p. Now we're going over here, 360p, and clear that screen. And where are we now? I'm not even sure. Even I get lost sometimes. Pull the plug it in again. It's fastest way back again. So there we go. That was a quick little demo there. There's line drawing, everything else you need to do with graphics. Very easy. If, for instance, I want to create 6 lines down the bottom here that do not scroll, that I can type in there. Well, there I go. I can type in there. So I clear the screen, and I'm still typing in here. And what I can do now is I can say up here, for instance, to draw a box, 100x, 100y is the corner, 200 wide, and 150 high. And we'll draw it with a red pen, draw a rectangle. Simple as that. So there's modules in there everywhere. I think we can even do the mandrel one here. I have one in here I can just try out. There we go. Doing a fractal. So it's not too bad. That's just running out of one processor at the moment. I'm not trying to do anything fancy. And all this forth, actually, even though I've taken a bit over 64K, it all fits within 64K. And we have plenty of room for video buffers, everything else. All the other guys are programming in C. Basically, they can do one thing, and that's it. In the meantime, I have plenty of room to expand, and I have all that memory, and I can access the SD card as virtual memory, any file as virtual memory, even serial RAM as virtual memory. And so I can use, it's a very powerful tool, and it's very fast. If I do the Fibonacci on there, I get 10 microseconds for 46, Fibo 46. And so, it's very fast processor, and as I said, and it doesn't slow down when we add extra processors to it. So I've probably used up my time now. I don't know how this came across, but next time I'll appreciate the feedback. Thank you.
Thank you very much, Peter. What an amazing talk and what an amazing demonstration. And I would say if it didn't crash, we wouldn't believe this is true. And so it's the proof of concept that it's really real and not something prefabricated. Great, great, great.